Hey, this is Tom, bringing you the fourth part of the Tom Simple Robot tutorial. We're going to talk about lights today. I happen to be very fond of lights and colors. I love Christmas time for that very reason. All the lights and colors. Not for the presents or Santa Claus or anything like that. Just the lights. I'm kidding. Anyway, to start things off, let's revisit our engineering document. That massive air quotes around that because it's just my simple drawing on graph paper. And as we can see, we have a third feature we need to address, which is that the eyes must light up. And we're going to facilitate that through the use of LEDs and do an Arduino sketch that controls those LEDs. So to start things off, I'll show you some examples that we can build on right from the Arduino tutorials. So taking a look at our main screen, we see that we have an example called Blink, which, as the name implies, allows an LED to blink. They show us how easy it is to wire it up. It's simply on pin 13, a resistor going into an LED, which then goes into ground, so you complete your little circuit. And there's a fairly simple sketch that accompanies it. I happen to have that opened already in the Arduino software, so we'll have a look. Let me zoom in to make it a little clearer. So as you can see in this sketch, they initiate the LED to pin 13, or I should say initialize, not initiate, to pin 13. There's the numeric assignment, and then there's the actual initialization of the pin. And then all they do is loop. And then they do a digital write high, a slight pause, and then a digital write low, and a slight pause. So on off with a slight pause in between. So when we load this sketch onto our Arduino, we expect to see it just blinking with a 1000 millisecond or 1 second delay. So with the Arduino now plugged in and ready to go, I'm going to upload this sketch to my board and we should see an LED blinking. Sketch is uploaded, let's have a look. So taking a look at our wired up Arduino, we see that we do in fact have a blue blinking LED on a 1 second interval. So a little word about how I have things wired up here. I wired up both this and the next example we're going to cover, which is called fading, on the same board to make things a little more simple. So all I've got is, this is my ground, and I've got, turn things around to make it a little more clear. This is my ground, this is my LED, and I've got this fellow completing, the resistor actually completing the jump from pin 13 over to the LED. So the exact, very simple circuit that they outlined is what I've got happening here. The lighting might make it a little bit difficult to see, but that is the actual wiring they prescribe. So that is what I've got set up, and it's fairly simple. So that's how you can make an LED blink. Let's take a look at a different example on how you can make one fade. So now we're going to talk about fading, meaning having an LED slowly and steadily brighten and then dim again in a very nice sort of up and down wave. To illustrate, we're going to use the fading example conveniently provided for us by in the Arduino tutorials. And you can just go to arduino.tc/en, in my case, tutorial fading, to check that out for yourself. And when we take a look at that example, we zoom in and see that we have a very simple wiring scheme. Once again, just a resistor, the LED, and then into ground. And they're using pin 9 this time, which if you look at both your Arduino board and the actual drawing here, has a PWM next to it. That's because the fading effect is accomplished using something called pulse width modulation. I won't get into that now because I'd probably have to go consult some old textbooks to understand exactly the principles behind it, but basically it lets you simulate a very nice analog wave or waveform, whatever it's called, but digitally. So it's so approximately precise that it looks very smooth to the human eye, and you'll see that as we actually show the example in action. So there's a nice wiring schematic for you to check out that shows exactly how to wire it up. And then we've got the associated sketch code here listed in the tutorial. Of course, I have it open in the Arduino software as well. So let's zoom in and have a look at it. So what they're doing is initializing the LED pin to 9, and then they are proceeding to loop. And they're doing 2 loops really. One is the fade from dim to bright, and the next is the fade from bright to dim. So here's the first one. They start off at a value that they call a fade value of 0. They set a target of 255, which is the maximum brightness, and then they step up in increments of 5. And they send to that 2-pin 9, whatever their value is, every step of the way. So 5, 10, 15, etc., all the way up until they get to 255, with a delay in between so that there's a nice smooth, easily perceived ramp up. So it's not just like an instant up, down, that would happen too quickly for it to really be appreciable. Then once they've reached their maximum of 255, in other words, once the condition for this loop is satisfied, they break out of it. They then come to the fade down loop, where they start off at that maximum value, the maximum brightness they started at of 255. And as long as they're over 0, they pop down by 5. So it goes 255, 250, 245, all the way down to 0, at which time they leave this loop and then go back to the top of the main loop and rinse and repeat. And it just happens over and over again. So 2 loops within a loop. And of course we see the same delay here for the same very nice smooth effect. So with that understood, I am going to upload this sketch, and we should see some different behavior, this time on the other LED that I wasn't using in the previous example. As you recall, I have them both wired up on the same board. Looks like the upload's complete. Let's take a look. So now if we take a look over at our actual Arduino, and I do a little manual zoom in so you can see, you see that our nice green LED, which is wired up over here on pin 9, nothing up my sleeve. That was 13 where we were before. This one's on pin 9, so the positive is coming over through the resistor into the LED, and then I'm using the same ground I was for the other example. So that's the completed circuit. You can see that we've got a very nice fading effect happening. Get that wire out of the way. Just very smoothly transitions up and then fades back down and then starts up again. Happens fairly quickly, but it's smooth, and you can contrast that with the blink that we saw in the previous example. So there you have an example of 2 things we can do with LEDs, and as well the fact that you can have the same Arduino, whatever you want to call it, build that can exhibit 2 completely different sets of behavior depending on what you upload. Now we're going to make things a little more interesting, and we're going to get into RGB, or red, green, blue LEDs, which have the capability to blend color combinations of red, green, and blue, or red, blue, and green. RGB, RBG, RB. I'll be right back. So to start off our RGB examples, I have a little sketch here I wrote based on the blink example that I showed first. In this case, I'm driving an LED, which I'll show you when I switch over to the camera, which is an RGB LED, meaning it has the ability to display all 3 colors. So let's have a look at the sketch that I wrote, and I'll explain it. So it should look familiar if you remember the sketch I showed a few moments ago for driving just the standard LED, except now I'm setting up 3 pins, 9, 10, and 11, assigning them each a number, and then setting them up here in setup. And then in my main loop, I'm basically cycling through each color that the LED has the capability to display. So I'm turning on red, I'm turning off red, I'm turning on green, I'm turning off green, I'm turning on blue, I'm turning off blue. Then I'm turning on all three so you get a nice white light, right? Because all colors combined don't form Captain Planet, they form white. I wonder if that's where the Captain Planet idea came from. By your colors, powers combined. Sorry, segue. Then I turn that one off, and I've got white light coming on and white light going off, and then I repeat the whole main loop. So it goes red on, red off, green on, green off, blue on, blue off, white on, white off, wax on, wax off. My comedy is in poor form today, but hopefully this sketch isn't. Let's take a look over at the Arduino and see if it works after I upload the sketch, and here I go. So now as I segue over to my camera view, and it occurs to me that I misused segue a moment ago, and I meant to say I was off on a tangent about Captain Planet. We take a look here and see that my sketch is working as described on the Arduino. We are cycling between red, then green, and then blue, and then over to white, which is all of them together. A little word about wiring as we take a look here. From my digital pins 9, 10, and 11, I have wires that are for red, green, and blue respectively jumping over to the breadboard. Then we pass things through some 1K resistors. I chose 1K because those met, and I suppose even exceeded, the resistor value outlined here on SparkFun's little data sheet, calling for 330, 150, and 150. And then into the actual RGB pins on the LED. And then I've got the single pin going to ground on the outside. This is what's known as a common cathode LED, meaning that there's one common negative for all three of the positive or color ends, or whatever you want to call them. Here is an example I'm showing you. This is the same type of LED, and this is your red, this long guy is your common ground, and then you've got green and blue, and that's exactly how I have that sitting on the board. Now I will illustrate the fading example using RGB, and that should be pretty cool to watch. So here we go. So let's take a look at the sketch I devised for doing some fading with an RGB LED, the same one I just showed you in the blink example. Zoom in and take a look at my sketch code for this one. Should look familiar. It is derived from the fading example that I showed a few moments ago, and set up the 3 pins, RG and B. I should note that in my previous example, I had the setup going on for the RGB pins for the blink example. I don't think that's necessary because 9, 10, and 11, because of the type of pins that 9, 10, and 11 are versus 13, which was in the original blink example. So it didn't hurt anything, but I don't think that was a required step. That said, into the main loop we go. And what I'm doing here is basically doing a fade from 0 to 255 and then 255 back down, first for red. And then I scroll down a bit, and you can see I'm doing the same for green. And then finally for blue. And then guess what? I'm doing it for all 3. So you see a basic a fade up to like bright white, and then a fade down to nothing. So the same basic concept as the blink example. I'm just putting this RGB LED through its paces. So let's have a look. Whoops. Let's have a look and see that in action. So here's my fading example in action. It occurs to me I didn't actually show you the uploading of the sketch while I was still in the screen view, but rest assured I did in fact upload that sketch. It did work, and we can now see that we are fading very gracefully through red, green, and blue. and then finally white, which is a combination of all three. Apart from the sketch, in this case, nothing else has changed. Same pins, same components, same everything. Again, showing the power and versatility of the Arduino platform. Or maybe not so much, but you get my point. So there's a nice fading example, and now I've showed a couple of examples for what kind of things can be done with an RGB LED. That isn't by accident. That is going to be probably my chosen component for lighting, for the little light setup I'm going to have in the robot's head ultimately. I want to be able to display any number of colors. I want to blink, I want to fade, I want to do all sorts of things, maybe at random. I haven't worked out exactly what I want the robot to do, but I did want to show all the different capabilities that were there. So what remains, I think, for us now to do is start to bring all the pieces together and work on sort of a master sketch for this whole thing, and maybe have everything wired up on one board. And with that done, with all the guts and the nervous system and everything all wired together, I think we'll be ready to get this sucker a body built, and then we'll have an up and running robot. And that, as they say, will be pretty cool. Well, I say. I hope you say. Anyway, come on back and see my progress. Before I go, I have a final addendum for you. I wanted to show you a different example, pretty much the same principle, but a slightly different example in one important way. As you can see here, I've got another proto shield with more or less the same wiring, a red, green, and blue wire jumping over from the I/O pins through the resistors and then into another RGB LED. This one is not diffused, which is why it seems like it has like crystal. It's made of crystal or something instead of like a more opaque material. But that's not really the principal difference I want to talk about. What I want to talk about is the fact that instead of a common ground, this particular type of LED, which is a common anode as opposed to a common cathode that I was showing before, has a common positive. So instead of jumping out, as I was with the black wire in the other example, to a ground, I'm jumping out to the 5-volt power. So it's an important difference because there are two types of LEDs you're going to encounter, and depending on what type you're using, you need to know how to wire it up. When I first started tinkering with this stuff, I really found myself confused, probably more than I should have been, by this simple tidbit of information. So I wanted to share it with you. And I also want to take a look at the sketch now to show you a difference in that. That needed to be made so that we could observe the same behavior between this common anode LED and the common cathode LED that I was showing before. Okay, so taking a look at this final sketch that I wrote, also based on the fade example that we started with, but a little bit different because of the fact that I'm using a common anode LED in this case. I'll zoom in and show you. Things look very similar. In fact, they would look identical if you didn't take a second glance and notice that basically what I've done is reverse the order in which I'm fading, so to speak. I'm starting off with a high value in the case of the anode and working my way down to 0, and then starting at 0 and working my way back up to the maximum value of 255. And that's because things are reversed now that I have a common positive instead of a common negative. And I'm sure there's all kinds of cool algebraic reasons why that is the case. Mathematical reasons, electronic reasons, blah, blah, blah. But what's important for you who are following in the steps of I, who am a rank amateur, to remember is that you've got to reverse things when you're using an anode versus a cathode. And so you see I did it for the red, I did it for the green, and I did it for the blue, and as well for the white. Starting at 255, stepping down to 0, then starting at 0 and stepping my way back up to 255. So just an important side note and a good way to wrap things up on our discussion of lights. Now we are pretty much ready to move on to getting the guts of this little guy put together and then figuring out what we're going to do in the way of a body. So see you next time, and thanks for joining me. Bye.